In the present lecture, we will discuss the unbalanced assignment problem. Unbalanced assignment problem means given cost matrix is not a square matrix, which means number of rows is not equal to the number of columns. In this situation, we add a dummy row or dummy column to make a unbalanced problem into balanced problem. Let's see the one example problem. There are 4 jobs to be assigned to 5 machines. Only one job can be assigned to one machine. The amount of time in hours required for the jobs per machine are given in the following matrix. Find an optimum assignment of jobs to the machines to minimize the total processing time, and also find out for which machine is no job assigned. What is the total processing time to complete all the jobs? Let's see the solution. Here given a number of rows are 4 and number of columns are 5. So number of rows is not equal to the number of columns. So this is a unbalanced assignment problem. To balance this one, we have to add a dummy row with 0 entries of the corresponding rows. This is a modified matrix. Here we add a dummy row with 0 entries. Now number of rows equal to the number of columns. Now we apply the Hungarian method to find the optimal solution. In Hungarian method, first phase is row and column reductions. For this, first step is subtract the minimum value of each row from the entries of that row. Now we determine the minimum value from the each row. In the first row, minimum value is 2. In the second row, minimum value is 10. In the third row, minimum value is the 1. In the fourth row, minimum value is the 6. Similarly, in the fifth row, minimum value is the 0. Then subtract the minimum value for all the rows. For the row 1, subtract the minimum value 2 from all the elements. Then first row will becomes the 4 minus 2. It is the 2. 3 minus 2, 1. 6 minus 2, 4. 2 minus 2, 0. 7 minus 2, 5. Then subtract the minimum value 10 from the second row. Then second row becomes the 10 minus 10, 0. 12 minus 10, 2. 11 minus 10, 1. 14 minus 10, 4. 16 minus 10, 10. Next subtract the minimum value 1 from the third row. Then third row becomes the 4 minus 1, 3. 3 minus 1, 2. 2 minus 1, 1. 1 minus 1, 0. 5 minus 1, 4. Next subtract the minimum value 6 from the fourth row. Then fourth row becomes the 8 minus 6, 2. 7 minus 6, 1. 6 minus 6, 0. 9 minus 6, 3. 6 minus 6, 0. Next we have to subtract the 0 from the fifth row. And here observe that all the elements in the fifth row are having the 0, and also have to subtract the 0. Then fifth row will be not changes. Next step is subtract the minimum value of each column from the entries of that column. Here all the columns are having the minimum value is 0. So no changes occurs in the matrix. After a row and column reductions, next we will go for the phase 2, that is optimization of the problem. In the phase 2, First step is draw a minimum number of lines to cover all the zeros of the matrix. For this, first do the row scanning. In the row scanning, start with the first row and observe the row. If there is only one zero in that row, then mark a square around the zero and draw a vertical line which is passing through that zero. In the row more than one zero, then skip that row. So in the first row there is exactly one zero and mark a square around that zero and draw a vertical line which is passing through that zero. Next, in the second row there is exactly one zero, then mark a square around that zero and draw a vertical line which is passing through that zero. In the third row there is no zeros, we have to skip the third row. In the fourth row there is more than one zeros, then we have to skip the fourth row. Similarly, in the fifth row also there is more than one zero, that is 3 zeros are there, then we have to skip the fifth row also. After scanning the last row, check whether all the zeros are covered with the lines. If yes, go to the step 2, otherwise do the column scanning. After the scanning of the last row, after the scanning of the fifth row, still zeros are exist in the matrix, then I have to go for the column scanning. In the column scanning, start with the first column and observe the column. If there is only one zero in that column, then mark a square around that zero and draw a horizontal line which is passing through the zero. In the column more than one zeros are exist, then have to skip that column. So in the first column already we are removed in the row scanning. Next we have to observe the second column. In the second column there is exactly one zero exist, then mark a square around that zero and draw a horizontal line which is passing through that zero. In the third column there is only one zero is exist, then mark a square around that zero and draw a horizontal line. So and in fourth column already we are removed by the row scanning, and in fifth column there is no zeros. Then after scanning of the last column, check whether all the zeros are covered with the lines. Here all the zeros are covered with the lines. Then I have to go for the step 2. Step 2 is the check whether the number of square marked is equal to the number of rows of the matrix. If the number of square marked zeros are equal to the number of rows of the matrix, then I have to go for the step 5, otherwise go to the step 3. So here square marked zeros are the only 4 and number of rows are the 5. Then the number of square marked zeros are not equal to the number of rows of the matrix. Then I have to go for the step 3. Step 3 is the identify the minimum value of the undeleted cell value. Here these are the undeleted cell values. Among these values we have to select the minimum value. So that minimum value is the 1. So minimum value of the undeleted cell value is the 1. After identification of the minimum value of the undeleted cell, then add the minimum undeleted cell value at the intersection points of the matrix and subtract the minimum undeleted cell value at the undeleted cell values, and remaining value should not be changed. So first we have to add the minimum undeleted cell value at the intersection points of the present matrix. Here these are the intersection points. So here we have to add the minimum undeleted cell value. So here, so job 4 and the machine A. Here intersection value is the 2. Here we have to add the minimum value of the undeleted cell value, that is the 1. So 2 plus 1, here it will become the 3. Similarly, job 4 and machine D is having the cell value is the 3. So we have to add the minimum undeleted cell value, that is the 3 plus 1 equal to the 4. Similarly, job 5 and the machine A, so there is the intersection value is the 0 and the minimum value of the undeleted cell value is the 1. So 0 plus 1 it is equal to 1. Similarly, another intersection point is the job 5 and the machine D. Their value is the 0. We have to add the minimum value of 1. So 0 plus 1 it is the 1. Next we have to subtract the minimum undeleted cell value at the undeleted cell values. So these are the undeleted cell values. Among these values we have to subtract the minimum value of 1. So 1 minus 1 equal to the 0, 4 minus 1 3 and 5 minus 1 4. Next 2 minus 1 1, 1 minus 1 0, 6 minus 1 5. So next we have to observe the job 3 row, that is here undeleted cell values are the 2, 2 minus 1 1 and 1 minus 1 0 and 4 minus 1 3. And next to remaining values we should not to change. So keep the same values. So this is the modified matrix. This is the modified matrix. Next, to draw a minimum number of lines to cover all the zeros of the matrix. In the first row there is more than one zero, then I have to skip the first row. Similarly, in the second row also having the two zeros, then I have to skip the second row. In the third row also having the two zeros, I have to skip the third row. In the fourth row also having the two zeros, we have to skip the fourth row. Similarly, in the fifth row also having the more than one zero, that is the three zeros, then I have to skip the fifth row also. Then I have to go for the column scanning. In the first column there is exactly one zero, then I have to mark a square around that zero and draw a horizontal line which is passing through that zero. Next, in the second column there is more than one zero, that is two zeros, then I have to skip the second column. In the third column also having the more than one zero, then I have to skip the third column. In the fourth column also having the two zeros, more than one zero, then I have to skip the fourth column. In the fifth column also having the more than one zero, then have to skip the last column also. After scanning the last column, check whether all the zeros are covered with the lines. Here zeros are not covered with the lines. So in this situation we have to apply the diagonal rule. In the diagonal rule, select the zero that is diagonally having the another zero in the opposite row or column. So first I have to go for the row scanning. So in the row scanning, if I selected this zero which is having the another zero in the diagonal position in the opposite row. So next I have to go for the second row, is already deleted by the column scanning. Next I have to go for the third row. In the third row if I selected this 0 which is having the diagonally another 0 in the opposite row, then mark a square around that 0 and draw a vertical line. So next in the fourth row, if you have to select this 0 which having the diagonally another 0 in the opposite row, then mark a square and draw a vertical line. In fifth row, there is exactly 1 0 and mark a square and, around that 0 and draw a vertical line. So next here I have to observe all the zeros are covered with the lines, then no need to go for the column scanning, then have to go for the step 2, that is here observe the square marked zeros are equal to the number of rows. Here square marked zeros are the 5 and number of rows of the matrix also 5. So number of square marked zeros are equal to the number of rows of the matrix, then I have to go for the step 5. So step 5 is the treat the solution as marked by the square. So in the matrix, here we are mark a square around that 0. This is how to treat the optimal solution. So next we have to calculate the optimal time of assignment. For this one I have to observe the initial balanced matrix. Similarly I have to mark a square with the respected positions. Then I have to go for the optimal assignment. So optimal assignment is for the job A assign the machine B, job 2 we are assigned the machine A, for job 3 we are assigned the machine D, for job 4 we are assigned the machine C, for job 5 we are assigned the machine E. So next we have to determine the time of the assignment. So for this one I have to observe the initial matrix. So here for job B, for job 1 and machine B, time is the 3 hours, and job 2 machine A, time is the 10 hours, job 3 and machine D, time is the 1 hour, and job 4 machine C, time is the 6, and job 5 and machine E, time is the 0. Then the total processing time will become the 3 plus 10 plus 1 plus 6 plus 0. So total processing time is the 20. And one more thing you have to observe here, for job 5 and machine E having the 0 processing time, which means here we are not having the any job 5. For the balancing only we are added the dummy job, that is the dummy row. And one more thing you have to observe, for the machine E having the no processing time. And this is the solution, and thank you.